Welcome to Module 3. Here's where you can download this spreadsheet to go with this video. So let's get started. Module 3 is very similar to Module 2. In Module 2, you learn about estimating population mean and the population proportion. So we just extend that to estimating the population standard deviation or the variance. And in this case, we'll be using chi-square distribution. So the steps are pretty much the same. Instead of using t-distribution or normal distribution, we'll be using the chi-square distribution. That's spelled C-H-I square, so that's pronounced chi-square distribution. We'll still be calculating the confidence interval, confidence level. The difference here is because chi-square distribution is not symmetric, we need to figure out, we have a different formulas for the left lower end and upper end for the confidence interval. So for the right hand side, it's this, and then for the left side, it's this. And we'll be using Excel to figure out the confidence interval. Just like last time, we need to determine the sample size required to estimate the sigma or the sigma squared. But in this case, instead of using Excel, we'll be using the table to determine the required sample size. So let's take a look at the critical values. So again, it's very similar to last time. You find out areas and then critical values, but the difference is that there's a left area, or the left tail area, and then the right tail area. And we need these two values because, again, chi-square is not symmetric. So using those two areas, we separately calculate the left critical value and then the right critical value using the function called chi-square.inverse, so CHISQ.INV. And for those of you who are Excel expert, for the right critical value, you can also use a function called the chi-square.inverse.RT. RT stands for the right tail. So if you would like to skip a step on calculating the right area, you can use this, but that's optional. So again, we calculate the left side and the right side because the chi-square distribution is not symmetric. So let's see how you can use this to calculate the confidence interval, which is in the next tab. So here's an example. A group of 22 subjects took an IQ test during a part of the study. So the subject had a standard deviation IQ score of 14.3. So that's the sample standard deviation. We want to construct a 95% confidence interval estimate of the sigma, the standard deviation of population from which the sample was obtained. We're going to assume a few things. That the sample is a simple random sample, and it's normally distributed, as you can see in the histogram over here. So the sample variance, the S squared, is the best point estimate of the population variance, sigma squared. So that's why S is given to you. The sample standard deviation is a commonly used point estimate of sigma. It is a biased estimate, but that's the best we got. So let's figure out the confidence interval, and this is the formula here. There's the left side and then the right side. So this requires n s squared and then chi-squared on the right and then on the left. So here's an s. What's the sample size? That's 22. So degrees of freedom will be 21. Confidence level was given to you, 0.95. So if you plug in these numbers, the rest will automatically calculate themselves. So the chi-square left side is 10.28. Chi-squared on the right side is 35.48. Using those values, we figure out the confidence intervals. The lower end is about 11. The upper end is about 20.4356. And these two replicate the formulas here. As you can see, there's a square root. So that's because we're taking the square root of the variance. So instead of calculating, if you already have the confidence interval estimated as sigma squared, like if you're given 121 or 417.6, then you don't have to go through all this trouble. Just take a square root of each number, and you get the range of 11 to 20.4. So based on this result, we have 95% confidence that the limits of 11.0 and then 20.4 contain the true value of sigma. If you want to estimate the sigma, you use chi-square using these steps here. Let's look at the sample size. Typically, I tell you to use Excel to figure out the sample size, but in this particular case, it's a real pain to do so within Excel. So instead of using Excel, we're just going to simply use the table. This table comes from the book. It's table 7.2. So how to use a table? Let me show it to you with an example. We want to estimate the standard deviation of all voltage levels in a home. We want to be 95% confident that our estimate is within 20% of the true value of sigma. How large should the sample be? So what's the minimum sample size, assuming that the population is normally distributed? So from the table, you find 95% here, and it's S, standard deviation. So go down to 20%, and then go to the right to find the minimum sample size required here. So for the 20%, it's 48. That's all you have to do. So from the table, you can see that the 95% confidence error and the error of 20% for sigma standard deviation correspond to a sample size of 48. So we should at least obtain a sample size of 48 voltage levels from the population of voltage levels. And that's all there is to it for Module 3.